everyone, you are welcome to my video. Today we are going to be looking at engineering mechanics. So we have some terminologies here that first I want us to comprehend before we dive into it. So what is engineering? We say engineering in simple terms is the practical application of science, mathematics, and creativity to solve problems, design new technology, and build structures or systems that makes life easier. That is engineering. So what is mechanics? Mechanics is the branch of physical and engineering concerned with the behavior of physical bodies when subjected to forces or displacement and the sequence effect on their environment. It covers the motions of objects such as kinematic, the forces causing motion, dynamics or kinetic, and the object at rest. So the object at rest is one referred to as statics. So this branch is divided into classical mechanics, which is the Newtonian for every object, and quantum mechanics for atoms and subatomic scales. But we will not dive into that much. So we will be talking about forces, the forces that act on an object. If an object is at rest, forces also act upon it. So let's consider something of this kind. If you have something of this kind, something like this. All right, so we have forces that are acting on this body. We have forces that are acting on this body, and this is Y and this is X, which I believe you already know. So here we termed it to be F1, and here we termed it to be F2. All right, so there is a resultant force in the middle. There's a resultant force in the middle. Here we have angle beta. It's not B, it's beta. And here we have angle theta. Now, for you to resolve this, for you to find these forces, you're going to resolve it in its component. All right, so for you to get the forces, you have to draw a parallelogram. Draw something of this kind, where here you have F2 and here you have F1. Here you have F1. So resolving this into its component, you're going to have you're going to have Y, as you are resolving it into what? Y component. You're going to have Y, which is equal to F1, because this is Y and this is F1. F1 is under what? Which angle? Which angle is between F1? Is cos beta plus F2, which angle is between F2 is going to be sine theta. And this is going to be equal to what? Fx. This is going to be equal to Fx. So if you have x here, resolving it into x component with respect to y, you are going to have F1. So what are you going to have? Okay, you're going to have sine beta minus F2. You're going to have what? Cos theta, which is equal to Fy. Now, to find the resultant force, remember this is a resultant force according to parallelogram, which I believe you know the law. So this is a resultant. So finding a resultant force, you are going to have Fr as a resultant force, which is going to be equal to the root of what? Fx square plus Fy square. For you to find a resultant force, you're going to have Fr, this is Fr, which is a resultant force, equal to Fx square plus Fy square. All right, so if you impute the values, you are going to find the what? The resultant force. resultant force. So for you to get the angle, the ratio of the angle, you are going to have tan theta equal to Fy over Fx. Fy over Fx for you to find the ratio of the angle. Now, if you take the resultant of these forces, you are going to have answer. So the answer you have for Fx and the answer you have for Fy, you put it Fy over Fx. Now, for you to find the exact angle, you are going to take inverse of what? Theta. You're going to take, tan. You're going to take tan inverse. So these are the basic principles or fundamental things that you are going to follow to find the angles that, or the forces that is acting on the body in a given question. So let's have example. All right, we have something of this kind. Let's have example like this. All right, so there's a force acting upon it when the angle between it is 30. Here the force is acting is 900 Newton. It's 900 Newton, and at this side is also a force acting upon it and is at angle 60 degrees, and this side the force is 800. So for you to get it, what are you going to do? Following the previous explanation we did here, you are going to draw a parallelogram. You are going to form a parallelogram. So you are going to form something like this, something of this kind, so that here you have your Fy and down here you have your Fx. So this is applicable also to this side. So here you have your F what? Here you have your F what? Okay, here you have your Fy and here you have your Fx. All right, this is the diagram. These are the forces that are acting. So these are the angles. So how can we find the resultant force now? How can we find the resultant force of this? Remember, you are going to see Fx. Fx is equal to what? It's equal to F1x plus F2x. All right. So Fy will be equal to what? F1y plus F2y. All right, that you are taking it into its component. All right, so Fx is equal to what now? From here, Fx is equal to 900, taking it in respect to x. So you have 900 Newton. Okay, 900 plus what? That is 900. The angle that is between them is what? 30. And so you're going to have 900 cos 30, because from the above, if you look at the above, this is the formula we are using, 900 cos 30. And then from the Fy, you have what? 900 sine 30. That you take it in respect to this. So if you are taking it in respect to y now, you are going to have Fx now is equal to be minus 800 cos what? The angle between them is what? 60. Minus 800 cos 60. And then Fy will be equal to what? Will be equal to 800 sine. Okay, 800 sine 60. All right. So let's find the angle in the x component. At this point, we're going to say Fx is equal to 900 cos 30 plus what do you have? There is a f, because this is fx. This from the question we say f1x plus f2x. So f1x is this one, while f2x is this one. All right. So we are going to have plus, open the bracket, minus, what do you have here? 800 cos 60. Close the bracket. Now for fy, you're going to have what? Fy is what? 900 sine 30, because this is fx1, this is fx1, and this is fx2. Don't be confused. Fy1 and fy2. So fy1 is what? 900 sine 30. Don't forget the degrees, very important. All right. So here the f2 is what? The f2 is what? Okay, you're going to have 900 sine 30, so the f2 is plus 800 sine 60. I hope it is clear. So what are we going to do? We are going to look for the sum of it. So 800 sine 30 into minus 800 sine 40 cos 60 is going to give you what? So if you punch your calculator, if you punch your calculator very well, you are going to have 886.33. If you approximate the other value, you have 33. So if you punch here, you're going to have 44.28 in 2 decimal places. So at this junction, what are you going to do? What are you going to do? What is the formula for finding FR? If you trace back, you see that FR is equal to fx squared plus fy squared. Now, if you apply FR here will be equal to the root of fx squared. Fx squared is what? This one. So you're going to have 886.33 squared plus what? Fy squared is what? 44.28 squared. All right. So if you punch your calculator on this one, okay, you have, if you punch your calculator on this one, you're going to have 887.44. That is, if you add this one, if you follow the formula above, you have fy square, fx square, and plus fy square. This is what you are going to have. So what is the ratio of their angle? Their angle is tan theta will be equal to what? Fy over fx. Fy over fx. So this is equal to, from the here you have that fy is 44.28. You have 44.28 over what? 8 over 886.33. So if you punch your calculator very well, 44.28 over 886.33, you are going to have 0.04. Approximately, you're going to have 0.05. Okay, so this is the ratio of their angles. This is the ratio of. So to find the angle, you take, this is the angle, you take tan inverse. So the tan inverse will be what? The tan inverse will give you the angle which is equal to 2.86. And this is the angle that you find in the forces from the above given equation. Thank you very much for watching my video. Do follow my video, like, share, and subscribe. Thank you very much.